You're late to a meeting. You glance at your watch. The second hand sweeps. You feel time passing. You know what time is? Here's the test. Don't tell me what time does. Don't tell me you measure it with clocks. Tell me what it is. What's actually there when you say time exists? What substance makes up a second? What flows when time flows? You can't answer that. Nobody can. But here's the thing that should bother you. You experience time every moment of your existence. Right now, you feel it passing. It seems more real than the chair you're sitting in. That chair is made of atoms. We can point to the stuff. But time might be the most visceral thing you experience, and it might not exist at all. Not in the way you think. Let me make this concrete. Take two events in your life. Breakfast this morning. Reading this sentence right now. You know that breakfast happened before this moment. You didn't decide that. You didn't construct it. The ordering feels given. Absolute, built into reality. Breakfast is in the past. This moment is now. That's not opinion. That's just true. Except it isn't. Not absolutely. Not universally. Right now, somewhere in the universe, there's a reference frame, a perspective, if you will, where these two events happen simultaneously. In another frame, you're reading this before you ate breakfast. The ordering isn't fixed. It depends on motion, on velocity, on where you're standing and how fast you're moving. Your brain is screaming at you right now. That's impossible. Things happen in order. First one thing, then another. That's what time is. Think about what you just did. You define time by invoking time. First, then, those words assume time already exists. That's not an explanation. That's not even a description. That's just naming your confusion and feeling satisfied. So here's where we start, with something you can actually do. Something that'll show you where your certainty comes from and why that certainty is an illusion. Pick up your phone. Open the stopwatch. Press start. Now press stop. You just measured time, right? You measured the duration between two events. But what did you actually measure? Be precise. Your phone counted oscillations of a quartz crystal. It counted 32,768 vibrations per second. That specific number because it's a power of 2. And engineers love binary. 1 second is defined as 9,192,631,770 periods of the radiation, corresponding to the transition between two hyperfine levels of cesium-133. That's not philosophy. That's the actual definition. Notice what happened. You measured time by counting periodic events, not by detecting some substance called time. You counted repetitions. Time isn't a thing you measure. It's the bookkeeping system for ordering changes. It's how we keep track of what happened when. Okay, you say, but those vibrations happen in time. The crystal oscillates over time. You're still assuming time exists. Yes, I am. And here's the crucial point. That assumption works brilliantly. We can predict, calculate, build GPS satellites and particle accelerators. The math works, but working isn't the same as being fundamental. Let me show you why your intuition about time is wrong. Not incomplete. Wrong. You think time is absolute, universal, that when you experience 10 seconds passing, I experience 10 seconds passing. Everyone everywhere experiences 10 seconds passing. Same rate, same flow, same now extending across the entire universe. That's false. In 1905, Einstein published a paper called On the Electrodynamics of Moving Bodies. Boring title. Revolutionary content. He started with two postulates. First, the laws of physics are the same in all inertial reference frames. You can't detect absolute motion, only relative motion. Second, the speed of light is constant for all observers regardless of their motion. That second one is the killer. Think about it. If you're driving 60 miles per hour and you throw a ball forward at 20 miles per hour, the ball moves at 80 miles per hour relative to the ground. Velocities add, but light doesn't work that way. If you're flying at half the speed of light and you turn on a flashlight, the light moves away from you at exactly the speed of light. 299,792,458 meters per second, not 1.5 times the speed of light, exactly c. Your brain wants to reject this. It should. It contradicts everything about how velocities work in your everyday experience. But it's not a hypothesis, it's a measurement. The Michelson-Morley experiment in 1887 showed this. They built an interferometer to detect Earth's motion through the luminiferous aether the supposed medium light waves traveled through. They measured light speed in different directions as Earth moved through space. The result, no difference, 0. Light speed was constant regardless of Earth's motion. This broke physics. If light speed is constant for all observers, something else has to give. What gives is time. Here's the thought experiment that shows you why. Imagine a train moving past you at half the speed of light. On the train is a light clock, a photon bouncing between two mirrors 1 meter apart. The person on the train watches the photon bounce straight up and down. To them, the light travels 2 meters up and down per bounce. At light speed, that's 6.67 nanoseconds per tick. But you, standing on the platform watching the train pass, you see something different. The light still moves at c, because it has to, but now it's moving diagonally. The train is moving forward while the light bounces, so the light traces a zigzag path. The distance is longer, the photon has farther to travel. At the same speed, and it must be the same speed, that's the measurement. It takes more time. You measure more time passing than the person on the train. Not because of measurement error, not because of signal delay. Actually, truly, more time passes for you than for them. Time is not absolute, duration is not universal. The rate at which time passes depends on velocity. This is time dilation, and it's not subtle. GPS satellites orbit at 14,000 kilometers per h. At that speed, time runs faster for the satellites than for us on Earth, about 7 microseconds per day faster. But they're also in a weaker gravitational field, which makes time run faster still, about 45 microseconds per day. Total 38 microseconds per day faster. That doesn't sound like much. But GPS works by timing light signals to nanosecond precision. If we didn't correct for time dilation, GPS would drift by about 10 kilometers per day. Within a week, it would be useless. Your phone's map app works because Einstein was right about time being relative. But it gets stranger, much stranger. It's not just that clocks tick at different rates. It's that the ordering of events, what you call past, present, and future, isn't universal. Two events can be simultaneous for one observer and sequential for another. Not just measured differently, actually, truly, in the fabric of reality, different. The question, are these two events happening at the same time, doesn't have a single answer. It depends on the observer's motion. This is called relativity of simultaneity, and it destroys the concept of now as anything universal. Your now, this moment you're experiencing, doesn't extend across space. There is no cosmic present moment that includes Earth and the Andromeda galaxy and everything in between. What's happening right now on Andromeda depends on your velocity. An alien standing still relative to Earth would say a certain event on Andromeda is happening now. An alien moving toward Earth at 1,000 kilometers per s would say that event hasn't happened yet. An alien moving away at the same speed would say it happened years ago. They're all correct. There is no fact of the matter about what's happening now at a distance. The present doesn't extend beyond your location. Now is local. Think about what that means. The past and future you believe in, fixed, determinate, real, they're not universal. They're perspective dependent. An event that's in your future might be in someone else's past if they're moving fast enough. So why does time feel so real? Why do you experience this overwhelming sense of flow, of passage, of moving from past to future? Because you're not equipped to experience relativity. You evolved at 5 meters per second, not 150 million meters per second. Your neural machinery builds a model of reality based on approximate constancy, the assumption that time ticks at the same rate everywhere, that simultaneity is absolute, that the order of events is fixed. That model works perfectly at human speeds. It breaks down completely near light speed. Your intuition about time is wrong because your intuition evolved for survival, not truth. But let's push further. Relativity tells us time is relative, that duration depends on motion. It doesn't tell us time doesn't exist. Maybe time is still real, just more complicated than we thought. Maybe it's like space, not absolute, but still fundamentally there, except that's not where physics is pointing. In general relativity, Einstein showed that gravity isn't a force. It's the curvature of space-time. Mass and energy warp the geometry of space and time, and objects move along the straightest possible paths, days through that curved geometry. Time near a massive object runs slower than time far away. Not because of any mechanism, but because time is part of the geometry, and massive objects curve that geometry. Black holes take this to the extreme. At the event horizon, time dilation becomes infinite. An outside observer would see you take forever to reach the horizon, frozen in time, asymptotically approaching but never crossing. But from your perspective falling in, you'd cross in finite time. You'd experience the interior. There's no contradiction. These are just different slicings of space-time, different ways of organizing events into space and time. This hints at something deeper. Time isn't a thing. It's a direction through space-time. Just as you can rotate coordinates in space, what I call the x-axis, you might call a combination of x and y. You can rotate coordinates between space and time. Change your velocity, and you're literally rotating what you call space versus what you call time. The universe doesn't split itself into space and time. We do, based on our motion. Now here's where it gets really strange. In quantum mechanics, time isn't even an observable. It's not an operator in the theory. Position? Yes. Momentum? Yes. Energy? Yes. Time? No. Time is a parameter, a background framework we impose to organize events, but it's not something the universe measures or stores. And in quantum gravity, the yet-to-be-discovered theory that reconciles quantum mechanics with general relativity, time might disappear entirely. The Wheeler-DeWitt equation, which attempts to describe the quantum state of the universe, contains no time parameter. It's a timeless equation. The universe it describes doesn't evolve. It just is, a static wave function encoding all possible configurations of space and matter. But wait, you say, we experience time. We remember the past, not the future. Eggs break, but don't unbreak. Entropy increases. That's not an illusion. You're right. But that's not time being fundamental. That's thermodynamics. That's the second law. The microscopic laws of physics are time reversible. Newton's laws work just as well forward and backward. Maxwell's equations work both ways. The Schrödinger equation is symmetric. Show a physicist a video of particles bouncing at the molecular level, and they couldn't tell you if it's playing forward or backward. But show them a video of a glass shattering, and they know immediately which direction is forward. Why? Because there are far more ways for a glass to be shattered than intact. There are more microstates corresponding to high entropy than low entropy. When a system evolves, it overwhelmingly moves toward higher entropy simply because there are more ways to be high entropy. You don't remember the future because memory formation is an entropy-increasing process. Memories are records, and records require low entropy initial conditions. The arrow of time, the asymmetry between past and future, isn't a property of time itself. It's a property of entropy. It's statistics. Time doesn't flow, entropy increases. You interpret that increase as flow. Carlo Rovelli, a physicist working on quantum gravity, puts it like this: time isn't fundamental, it's emergent. It's a feature that appears in our description of the universe, not a feature of the universe itself. Just as wetness isn't a property of individual water molecules, but emerges from their collective behavior, time emerges from the statistical behavior of matter and energy. The universe doesn't have a clock. It has configurations, and we label some configurations earlier and others later based on entropy. What you call the passage of time is your brain tracking increasing entropy. Let me connect this to your direct experience. Right now, neurons in your brain are firing. Electrochemical signals are propagating. Synapses are changing. You're forming memories of reading these words. All of that is entropy increasing. You couldn't form these memories if entropy were decreasing. The molecular machinery doesn't work that way. Your sense of time passing, of moving from moment to moment, is the feeling of your brain state evolving toward higher entropy. You're not detecting time, you're detecting change. And you're orienting yourself with respect to entropy increase, calling the low entropy direction past and the high entropy direction future. There's no substance called time that you're moving through. There's no flow you're being carried by. There's just configuration space, the space of all possible arrangements of matter and energy, and the statistical fact that you're almost certainly in a region of high entropy, having come from lower entropy. That's why time feels real, because entropy increase is real, because change is real, because your memory formation is real. But the metaphysical thing you call time, that might be as illusory as sunrise and sunset. Useful descriptions of real phenomena, but not fundamental features of reality. The ancient Greeks thought the sun moved across the sky. We now know the earth rotates. The motion we see is real. The sun does change position relative to us, but our interpretation was wrong. The sun doesn't actually move around the earth. Similarly, change is real. Entropy increase is real. But time is a fundamental flowing thing. That might be the wrong interpretation. So why does it feel so real? Why can't you shake the sensation that time is passing right now, that you're moving from past to future? Because you're made of matter obeying the second law of thermodynamics. Your neurons form records, and record formation is directional. Your consciousness is a process, and processes have directionality given by entropy. You can't help but experience the arrow of time because you are an arrow of time process. It's like asking why fish feel that water is real. They're made of molecules, surrounded by molecules, evolved in molecules. You're made of entropy-increasing processes, surrounded by entropy-increasing processes, evolved through entropy increase. Of course, time feels real. Your entire cognitive apparatus is built on the assumption of temporal order. But feeling real isn't the same as being fundamental. Here's what we actually know. Duration depends on velocity and gravity. That's relativity, tested to incredible precision. The ordering of events isn't absolute. That's relativity of simultaneity. Unavoidable once you accept constant light speed. The arrow of time comes from entropy. That's thermodynamics, not a property of time itself. Time might not appear in the fundamental description of quantum gravity. That's speculative, but motivated by serious theoretical work. Here's what we don't know: whether time is truly emergent or truly fundamental. If it's emergent, what exactly it emerges from. How to reconcile the apparent flow of time with the time-reversible laws of physics. Why the early universe had such low entropy, giving us an arrow at all. Whether there are parts of the universe where entropy decreases and time runs backward from our perspective. That's where the chain ends. That's what honest physics looks like. Not mysticism, not certainty where there is none. Just here's what we've measured, here's what the math says, here's where the edge of knowledge is. But here's what you need to understand. The fact that time might not be fundamental doesn't make it less important. It makes it more interesting. Wetness isn't fundamental. It's how we describe collective molecular behavior. But that doesn't make wetness illusory or unimportant. It means we understand wetness better. We know where it comes from. Same with time. If time is emergent, we have a shot at understanding why the laws of thermodynamics exist, why entropy increases, why the universe had low entropy initially. Those are questions we can't even ask if we treat time as fundamental and mysterious. The project of physics isn't to explain everything in terms of familiar concepts. It's to find the actual fundamental things, describe them precisely, and show how everything else, including your familiar experiences, emerges from those fundamentals. You still experience time. You still remember breakfast before lunch. You still arrive late to meetings. None of that changes. What changes is your understanding. You now know that the feeling of time passing isn't evidence that time is fundamental. You know that simultaneity is frame-dependent. You know that the arrow of time is entropy, not time itself. You can't unsee this. You're stuck with it now. Every time you check your watch, every time you say that happened before this, you'll know you're using a bookkeeping system for ordering changes, not detecting a flowing substance. You're tracking entropy, not moving through time. The universe doesn't have a clock. It has configurations. Change is real. Time might not be.